In 1974, a Princeton physicist named Gerard K. posed a question that quietly shattered our entire concept of space colonization. Is the surface of a planet really the best place for an expanding civilization? Think about it. Planets are massive gravity wells that trap you at the bottom of a pit. They suffer from unpredictable weather, volcanic activity, tectonic shifts, and finite surface area. Mars, for all our romanticizing, is a freezing, airless desert coated in toxic perchlorates. O'Neill realized something radical. We don't need to find another Earth. We can build one. Enter the O'Neill cylinder, an artificial megastructure 4 miles wide and 20 miles long, housing millions of human beings inside an engineered paradise. On the outside, a steel hull exposed to absolute zero, deadly solar radiation and vacuum. On the inside, artificial rivers, pine forests, urban centers, clouds drifting through engineered air, and blue skies curving up over your head until they meet the far city street directly above you. Tonight, we step inside the blueprints of humanity's grandest architectural monument. We explore how physicists plan to build a floating island in deep space, and the quiet, claustrophobic nightmares hidden inside an artificial world. Chapter 2: Forging Artificial Gravity. If you want to keep human beings alive without their skeletons dissolving and their hearts failing, you need gravity. But space has none. O'Neill's solution wasn't science fiction anti-gravity fields. By spinning a 4-mile-wide cylinder at roughly 1.4 revolutions per minute, the rotational force pushes everything against the inside surface of the outer hull. To an inhabitant standing on the curved ground, it feels completely indistinguishable from Earth's 1G gravity. You look down, and your feet are planted firmly on soil. You look up, and there is no open sky. Instead, you see the opposite side of the city hanging upside down above you, separated by 2 miles of atmosphere. But there's a catch that almost derailed the entire concept. If you spin a massive, isolated cylinder in space, a physical phenomenon known as gyroscopic precession takes over. The cylinder will begin to wobble, tumble out of control, and tear itself apart at the seams. To fix this, O'Neill designed them in pairs. 2 identical cylinders, 20 miles long, linked by a massive mechanical bearing assembly at each end. They rotate in opposite directions. The angular momentum of one cylinder cancels out the other, locking the entire complex permanently toward the sun with absolute stability. A silent 40-mile-long mechanical pendulum swinging through the void. Chapter 3: Catching the sun. How do you light a world wrapped in a steel tube? You can't just hang a giant light bulb down the center axis. The energy cost would be staggering, and the light would feel cold and unnatural. O'Neill's blueprint divided the cylinder's round hull into 6 alternating longitudinal strips running down its 20-mile length. 3 strips are land, thick, soil-covered hull plates where cities, farms, and forests sit. The other 3 strips are colossal, reinforced quartz glass windows. Hanging outside the cylinder are 3 long, motorized mirrors. By slowly angling these mirrors toward the distant sun, engineers can bounce natural sunlight directly through the glass panels and onto the land below. To simulate morning, the mirrors open slowly, casting long shadows across the interior hills. At noon, they lock straight overhead. To simulate night, the mirrors fold flat against the hull, blocking the sun and plunging the interior world into darkness, revealing the stars shining through the overhead windows. Think about that daily rhythm. You sit on your porch in a suburban neighborhood, looking up at a sunrise reflected off an exterior mirror, knowing that just 3 inches beneath your feet, on the other side of the dirt hull, is a lethal vacuum at minus 270 degrees Celsius. Chapter 4: The Shielding and the Atmosphere Building. An O'Neill cylinder requires vast amounts of raw materials, tens of millions of tons of steel, glass, and aluminum. Dragging that mass out of Earth's deep gravity well is financially impossible. This is why O'Neill's vision relies directly on the asteroid belt and the moon. Electromagnetic mass drivers, giant railguns mounted on the lunar surface, would launch bags of lunar dirt and rock into orbit. Automated space factories would catch this material, refine the titanium and aluminum, and cast the hull plates. And that raw lunar dirt serves a second, far darker purpose: radiation shielding. To protect millions of inhabitants from cosmic rays and solar flares, the outer hull cannot just be a thin sheet of metal. It must be coated in a layer of slag, regolith, and water nearly 5 to 6 feet thick. A massive, dead, rocky armor plate surrounding a living green ecosystem inside. Inside that armor, engineers must create a self-sustaining atmosphere. Because the interior air volume is so colossal, thousands of cubic miles of nitrogen and oxygen, an O'Neill cylinder forms its own microclimate. Warm air rises from the curved ground toward the zero-G center axis, cools and forms natural clouds drifting mid-air inside the tube. It rains inside the machine. Chapter 5. The Psychological Cage. Now, step out of the engineering diagrams and look at the human reality. What does it do to the human mind to grow up inside an inverted world? Psychologists who study extreme environments point to several haunting conditions that would inevitably emerge inside an O'Neill cylinder. First, the inversion paradox. On Earth, we look up to infinity. The sky is an open expanse. Inside a cylinder, when you look up, you see the geometry of human civilization staring back down at you. You see roads, buildings, and lake beds suspended over your head. The horizon doesn't fade into the distance. It curves up and around to crush you. Second, Coriolis vertigo. Because the cylinder is rotating, moving objects behave strangely. If you throw a ball straight up toward the axis, it doesn't travel in a straight line. The rotation of the floor beneath your feet causes the ball to curve unnaturally in midair. If you run east, in the direction of the spin, you feel slightly heavier. If you run west, against the spin, you feel lighter. Every step you take reminds your inner ear that your world is a giant spinning centrifuge. And then, there is the absolute fragility of life. On Earth, a war or a power grid failure is a disaster. Inside an O'Neill cylinder, a single structural breach in the quartz glass strips, a failure of the counter-rotating bearings, or a sabotage of the air scrub implants means total, unyielding extinction for millions of people within hours. You are living inside a giant, pressure-sealed glass bottle floating in a firing range of meteorites. Chapter 6. The Arc of Humanity. Gerard O'Neill didn't just design a station. He designed an escape hatch. If humanity remains bound to the surface of Earth, our existence is a ticking clock. A supervolcano, an asteroid impact, a nuclear war, or a runaway climate collapse can wipe out 4 billion years of biological evolution in an afternoon. O'Neill cylinders offer something planets never can: total mobility. Equipped with ion drives or fusion engines, these massive habitats don't need to stay in orbit around the sun. They can become slow, self-sustaining interstellar arcs. Generations of humans could live, love, build and die inside a green sunlit tube, traveling through the freezing dark between stars for centuries, carrying a piece of Earth's biosphere across the void. We don't need to find a new world among the stars. We just need the courage to build one.